New to Mesa this semester? Most of you, good. We use Canvas at Mesa. Canvas basically is a bulletin board. In the old days, we used to use Blackboard, and it was great. Canvas is better. I can do a lot more things. Canvas is how I put things up for you to come and grab. It is not meant for any form of communication whatsoever. Now, having said that, 99% of the students think, hey, I'll use Canvas as an email, and I'll send all my work. I will never know that you emailed me or sent work. Occasionally, I'll get an email saying somebody tried to contact you through Canvas, and then it laughs. Canvas is a bulletin board. That is it. It is a one-way communication from me to you. You can't communicate through me unless I actually set it up, and that requires a separate degree to figure that out. So if you want to email me, use my email. It's on the syllabus. I check my email probably 20 times a day. So yeah, never send anything through Canvas. It can't get to me. If you sent me a document, it would automatically delete it as a virus. It's not possible for you to send me something through Canvas. And I don't have it set up. Some classes will do their quizzes through Canvas. So you log on to Canvas and you take a quiz on Canvas. You're not downloading and sending anything. You're actually doing it on Canvas. That's way too much trouble. You know, I'd rather just sit down, pencil and paper, and then hand it to me later on. So Canvas is how you're going to do things. So this is our home page. Everything in the course is going to be over here under modules. It makes it really easy. I've been using this for a while. In fact, I'm actually the first person in the district to use Canvas by accident. I teach an early summer accelerated 6-week calculus course every summer. So I literally would start a week after the spring ended, and that's when the district converted to Canvas. So I had to learn Canvas like in a day or two. And every day I was going up to the loft and asking the experts, okay, now how do I do this? How do I do this? So by the end of the summer, guess who got to do the entire math and science presentation of how to use Canvas? Me. Because I was the only one who'd ever used it, and I had to figure everything out. Now I love it. It took forever to get used to, though. So I have it segregated here as notes, live lectures, quizzes, exams. So right off the bat, your syllabus is here, your schedule is here. There's a gigantic section of formulas. How many have a physical book right now? Does your book come with like a tearaway formula thing?
No, not the one I have currently.
Oh, that means somebody probably already removed it. Most books come with several pages of tearaway formulas, but if you bought a used book, guess what? Your previous owner has the tearaway formulas. I redid all of them and made them a little cleaner and everything else, so I put them on here, so you don't have to have any of the formulas from your textbook. You'll have them all here.
What's the Wi-Fi password so I can follow?
Oh, SD Mesa Fall.
Okay, thank you.
Has anybody logged on yet? Did that work?
I think it's SD Mesa Fall 2022.
Oh, 2022, sorry. And it's one continuous
just all
visit.
all caps?
Yeah. I don't know, honestly, I never tried it. Somebody
No
else in
caps.
my class yesterday, but they
I
said
think-
that was it. So.
Yeah, I actually was walking around yesterday asking people, do you know what the Wi-Fi, asking my own students who've been here forever, they go, no, I don't remember. I think all they do is change it every year to the particular semester. Okay, so everything is located on Canvas. So for example, your first quizzes, they're already here. Now, I want to go right to the schedule because this is basically our guide for the whole semester. So when you open something up on Canvas, you click on it, okay, you can't really print this screen. And a lot of things you'll want to print. So here's what you do. See where it says download schedule? Click that, and now something will come up in the lower left corner. Click that. Now it will open it up on your computer. It takes a couple seconds. This part is kind of slow on all computers. These computers are the slowest computers because these are the original computers that came with the building. So they're, I don't know how old they are, but they're really old. Okay, so then I'll click that guy here. This is our schedule. This is what we're going to do every class for the entire semester. We will not deviate from this. We will not get ahead. We will not get behind. So you'll know exactly what's going on. The schedule is made to follow this book here. It's the Essentials of Statistics. I like the paperback. I used this book. I used the first, second, third, and fourth editions. Literally for 30 years I used this book. I like it because the author is actually a community college statistics professor. And he explains things the way I explain things. And when I read the examples, they are relevant and they're really, really easy to follow. A lot of people don't like it. They say it's not rigorous. There's not, he doesn't prove things enough. Well, I have a graduate degree in statistics, and that's when you do stuff like that. You don't need that in 119. In fact, your upper division statistics, they may prove things. You know, you want to know how to do statistics. So this is a really great book, and the ebook, which is all the bookstores making available, by the way. I went down there and talked to Scott Krause, who's running the bookstore. He said the publisher provided them with no copies of the book. He said they're only selling the ebook. How many have an ebook, by the way? 40 bucks? Does that sound right?
Oh, yeah.
About 40 bucks. I don't like ebooks. This is my personal preference. I hate ebooks. I'm on my computer way too many hours every day anyway. And when I'm doing a textbook, the last thing I want to do is sit in front of my computer and do the textbook, and I don't have the patience to scroll. And it took 3 weeks for the publisher to send me this desk copy, so I was having to do the ebook, which was taking forever to go from one thing to another. But most of you grew up with these, and you're like, oh, I'm great with them. The other thing is it's really hard on the eyes after a while. So if you want to do an ebook, I'm not going to discourage you. I'd rather sit outside on the patio and look at my textbook, or go to the beach and look at my textbook. I don't want to have to take a laptop with me everywhere I go, but that's just my personal preference. The ebook is fine. If you want to get a hard copy, what they're selling is the 6th and 7th edition. Get the 6th edition. It will be way cheaper. In other words, the newest edition is always going to be very expensive. So if you buy it used, buy it online. I teach a linear algebra course. Okay, that's Math 254. The textbook is about $250 brand new. So I tell the students, go back one edition, and they're finding it for $20 to $30 online. And there's almost no change from edition to edition. So if you want a hard copy, buy one online, but buy the 6th edition, not the 7th. Okay, because there's really no difference, except the price. And you do need a text. Now, here's what we're going to do in class. I'm going to lecture every day for a period, or I'm going to record the lecture, and then I will stop recording. We're going to work in class. If you play your cards right in this class, you literally will never have to do any homework. Yet you're going to do a ton of work, but I want you to do all the work in class. They've provided us with 3 hours. Normally this class is 85 minutes. We get 3 hours, which means that everything we do, and every thing that you would have done tomorrow night at home, or on the weekend at home, you can do in here before you leave, and we will practice problems before you leave. And so you can actually be an expert at this class without ever having to do it outside of class. That's a huge advantage. I did this class last semester, 119X, and everybody in the class did the same thing. They did everything in class, and this is the first class I've ever taught at Mesa College, where every single person in the class, every person in the class got an A or a B. I teach Calc 3. Calc 3, my class averages are never below 90%. Those are the really elite calculus students, but there will still be C's. There will still be C's. Most of these A's and B's, but there'll still be C's. There were no C's in my stats class last semester because they did everything in class every single day and never left, not knowing what to do. And it was a great advantage. I wish we could do this in every class. We can't. Only the X classes we do this in. Now, you see introduction, 1, 1, 1, 2. Again, that goes by the sections in the book. Then you see quiz 1 Tuesday. So here's how it works. There's going to be 26 lectures in the course. There will be a quiz that goes exactly with that lecture. The stuff we do today and practice today, that will be the material on quiz 1. All quizzes are open book. You're going to do them on your own. Heck, if you're really fast, you could even do it before you leave class if you like. So you're going to do quiz 1, and you're going to turn it in when you come to class next Tuesday. So all quizzes are due 2 classes after the material's been presented, even though you'll probably have it done way ahead of time. You can always turn in things early. I would really rather you don't in general. And the reason is if everybody's turning things in a different time, I got to kind of keep track of everybody's stuff. And the one quiz that got turned in on a different day is the one I've got to carry everywhere I go, so I don't lose it. So I'd rather you just turn them in the day they're due. But if you want to turn it in early, you can always turn it in early. You can't turn it in late because I post a key. Plus, you have a due date and time. I'll actually have people say, well, I didn't think it was serious. A due date and time? You have a job interview at a particular date and time, and you didn't think they were serious about that. Yeah, you're probably not getting the job, right? You probably should show up. There was a football game at a particular day and time, and you're on the team, and yeah, you probably should show up at that day and time. Yeah, there's no gray area on the due dates. Now, if you notice, go down here to see 913. It says 4445, and I give you 2 little slashes. That's my way of indicating to you that's the last material that will be on that exam. Okay? And then the exam is 3 classes later. I do this by design. All quizzes are due 2 classes later, and the exam is 3 classes after the material is finished. Why? Because there are 7 lectures on the first exam, and notice quiz 7 is due before the first exam, which means you will have been quizzed on every single detail before you're tested. There are no mystery questions. There are no unknown questions. There are going to be no questions on an exam that you haven't already done in class, practicing homework, on a quiz. Plus, I give you a practice test with a key on the day we finish the material. So you also have all sorts of additional practice material. So when you walk into an exam, you've done every problem multiple times. The only thing you don't know is what numbers I'm going to use. You already know what questions I'm going to ask. I do this in all of my classes. Okay? I do that because the whole point is to prepare you so that you can say, yes, I can answer questions related to the material I've learned. We've probably all had that class where you sat down and took an exam and you looked at the question and say, we never talked about this. That's a bad question. No, you should be able to write the exams for me. You know exactly what's going to be asked. And you, again, I just give you different numbers maybe. So as we go through here, at the bottom, this is the part that needs to go on your refrigerator. The important dates here. This is when everything is. The drop deadlines, the exams, everything else. Now, are you going to get through this whole semester unscathed? I don't know. I just taught a 6-week Calc 3 course, and I had 3 different students during the course test positive for COVID and miss at least an entire week. All of them were healthy young men who had been boosted, and all of them really got their butts kicked and missed at least a full week. Okay? The previous year, I had I was the only person that came back, by the way. Last fall, when we were allowed to come back, I was the only person in the entire district who came back and taught live classes. So all the students who came back had to be either boosted or had to provide negative tests every single day. No incidents in the fall and spring. I had 3 in one 6-week class. It's probably going to happen that somebody gets sick during the semester. It's almost unavoidable. I have close friends and family who've already, this year, 2022, have already gotten COVID twice. Now, they didn't get deathly ill or anything, but they've gotten it twice already. I have a young friend who's gotten it twice this summer. This summer. I didn't think you could do that. But so we know it's out there. So if that's you, 2 things. I'm recording the lectures, so you can't afford to miss the lecture. Second, you can email me your quizzes. If you did the quiz, I want you to get credit for the quiz. How many have to drive a distance to get here? You know, maybe coming from North County or something. So, of course, you have total control over the traffic every day, right? You know exactly how many cars are going to be on the road. No, that's the worst commute possible. Anybody go 15? I-15? I-15 south in the morning is the worst commute. So, you do?
Yeah, I'm coming from South Bay, like go distance.
That's not as bad as coming from Escondido. Just trust me, I've done that commute. South of LA, that's the worst commute in California. You have no idea how long it's going to take you. So here's what's going to happen. Quiz is due at 8 o'clock. You got the quiz right there, and that's the day it takes you an extra hour to get to school. So what all of my students do in the 8 o'clock classes is, before they come to school, they get out their cell phone, they take a picture of the quiz, and they send it to me. There's 2 different apps. There's a Fast Scanner app, and there's something called the Cam Scanner. They're basically the same thing. Go to YouTube. There's a 1-minute tutorial on how to use it. Even I can use it, and I'm technologically challenged for things like that. It is so easy. You take a picture, you send it. You don't download it to your computer, you don't convert it, you don't do anything. If you said, oh, there's a really cool car outside, I want to take a picture of it and send it to my friend, would you convert it on your computer and do all? No, you're taking a picture. Send me the picture. The majority of my students do this for every quiz, and they say it takes them literally 10 seconds from beginning to end. This is insurance. This is to protect you on that day when you couldn't get here, right? I'm particularly talking about traffic, or you woke up sick. So you just send me the quiz before 8 o'clock. That's it. Now, when you get here, physically turn in the hard copy. Doesn't matter. But what if you're absent that day or you don't get here? Then the next time you see me, you physically turn in the hard copy. You already sent me the quiz. You turned it in. You're good. That's your insurance. That's your protection. Most people don't do this. To me, it's kind of a no-brainer, and it's particular to the 8 o'clock students because you're the only ones who have no control over the traffic. I have 11 o'clock class. Those people are never going to have a hard time getting to class. They might have a hard time parking, but never getting here. But the 8 o'clock folk, because of traffic and concerns like that, plus the fact that some of you may end up getting sick during the semester, You can send me every quiz. I don't need anybody to email me a quiz. But most of you probably would find it a really good idea just as protection to make sure that way I got it turned in just in case, you know, something goes wrong. Somebody have a question about that? Yeah.
So we take quizzes at home?
Yeah, you're doing your quizzes are open book. You have a week to do the quiz, but the due date and time is very specific. Now, the question I get asked in every class is, do I need to print the quiz out? I think it's wise. Now, it doesn't really make any difference to me. You can turn in your answers. But like I said, I teach calculus and above primarily, and about half the students don't print their quizzes. That's fine. The half that don't print their quizzes, almost every single one of them on every single quiz will make an error because they copied the problem incorrectly. They did a different problem than I asked. Because they're writing down things, they don't have the problem in front of them. The reason I like it when people print quizzes, you can't possibly do the wrong problem. It's right there in front of you. Plus, one of the most effective ways to prepare for an exam is to retake your quizzes. And if you've already got the questions right in front of you, then you practice them again later on. I don't need you to print the quiz, but it's very wise to do so. And on the first quiz, I'm asking you to put all the answers on the quiz because it's all vocab. Most of the quizzes, there's calculations and, you know, calculator work. So you're going to do all your work and show everything. Again, you don't need to print the quiz, but what I prefer is you print the quiz and then just staple it to the work and then turn it in most of the time. And that way you have a clean quiz to practice later on. That's just good practice. I believe it costs 10 cents to print a piece of paper on campus. How many here have a printer at home? Those are, oh, good. I asked a class yesterday, no hands went up. I thought, wow. Printers are really practical things, you know, especially if you want to, you know, I don't know, I have to send things all the time. I'll have to scan them and send them, and, you know, just nice having that printer. Although the printer I have is not very good and trustworthy, but it's still a printer. So this is what we're doing on a daily basis. Exams. Okay, on the syllabus, if you've looked at it, you're going to take 26 quizzes. Your top 20 quizzes are what's going to count. So you have a few mulligans there. You have a few freebies. You don't want to skip any quizzes because that's material that you're going to be tested on, and you want to make sure you can do it. But your top 20 will replace your worst exam if your top 20 is better than your worst exam. And for most people, it will be, because I throw bonus questions in there occasionally. And so last semester, about 20–25% of the class had quiz averages of over 100%. Because they would get everything right, but I'd throw bonus questions on periodically, they'd get those. Right? So they get more points than it was worth. Wise to do the quizzes, wise to do well. Something I do in this class and in this class only. I don't do this in any of my other classes. You're allowed to redo quizzes. Primarily it's because some people just don't do the quiz. I'm going to give an alternate version of each quiz during the semester. So if you turn in a quiz and you nailed it, you don't worry about it. You forgot to do the quiz. You got a 0, obviously. Or you did the quiz and it was pretty iffy. I will give an alternate version of the quiz. By the way, the person who gets 100% on the quiz is still probably going to do the alternate version as extra practice. They're just not going to have to turn it in. But you can redeem some of the missed points. You can redeem 50% of the missed points. So you didn't turn in a quiz, you get a 0. You do the alternate version, you can get half of those points. You did a quiz, the quizzes are worth 30 points. It's just arbitrary. So you did a quiz, you got 20 points. That's not a very good quiz. So you do the alternate, you nail it, you can get half of those 10 points back, that kind of thing. And the reason I'm doing that is so that nobody is skipping problems and skipping things. When you skip things, then you show up for an exam unprepared because there's entire concepts that you just sort of ignored. And in this class, things do build on each other. Okay? This isn't algebra. I hear people tell me all the time, statistics is so hard. As a math class, statistics is the easiest math class that exists on planet Earth. You take the square root occasionally. You add things. You multiply things. And that's pretty much it. You don't do any math. You add things and divide by the number of things to find averages. Occasionally you take the square root. I don't say that jokingly. Statistics is not math and you have a calculator for everything. Statistics is about interpretation and conclusions. If I gave you information, the idea is that everybody would come to the same conclusion about that information. You're going to have to do a calculation to produce a number, That's trivial, that's easy. That's never hard in any situation, the calculation, because you're gonna have a formula in front of you and a calculator. But making the right conclusion is the whole point of statistics. And that's, the world runs on this kind of thing. Statistics, again, I'm a little bit biased. I have a background in statistics and I've taught it for years and years. I think statistics for most human beings is the most relevant course they take in college. It's the only course that on a daily basis, you can go out there and say, oh, now I know why. I'm watching a commercial on TV, now I know why they can say that. I'm watching a political ad, now I know why they can say that. Because I understand how to interpret the information and the numbers. I don't have to do the calculation. I just have to understand how the interpretation works. So most people think of statistics primarily in relation to things like pharmaceuticals. Yeah, pharmaceutical companies are the largest employer of statisticians because you're testing a new drug and you want to know if it's safe or it's effective and things like that. We're going to talk about that kind of stuff, but there's also other simpler things about that, right? Just even results. So this is the course right here. This is what we're going to do. Okay, any question on the schedule and stuff? Okay, you guys all have a syllabus, you have access to it. If you've not logged on to Canvas, please do so sometime today to make sure you know the route. I will get emails every single day. Someone will say, I don't know how to get on Canvas. You have access to Canvas because you're enrolled in the class. You're going to put your student ID number in there, and then it's going to ask you for a password. Does anybody know what the password is automatically?
Your birthday.
Your birthday. So hopefully that's not one that you miss. Now, I don't know if it gives you the option to change the password. I don't know if it even matters. But it's pretty easy to get on. And you see the home page. The syllabus is on the home page. But then basically always go to modules for everything. Okay? Now, what I do is I download, or I shouldn't say download, I upload all of my videos to YouTube, and then I take them from YouTube and put them on Canvas. So you don't have to go to YouTube. You don't have to search it, try to find it. It would be really, really difficult. I actually searched Michael Brown on YouTube, and I literally scrolled for an hour, and I hadn't got to any of mine. There's a lot of Michael Browns on YouTube. But then I put Michael Brown, calculus. I have over 500 YouTube videos right now, just since the pandemic started. So what happened was on March 11th, 2020, that's the day the world stood still. That's the day the NHL and NBA seasons got postponed. The next day, the entire state of California basically said, we're done, you guys are all going home. And they told us, hey, we're going to do everything online now. This is my 37th year at Mesa College. I know what you're thinking. He's not that old, but yeah. 37th year at Mesa College. We only had 2 classes ever taught online. And they were both stats classes, by the way. And there were only 2 professors in the entire district. Now, all of a sudden, everything's 100% online and asynchronous. So we had to change on the fly, and nobody had any idea. I never considered doing an online class. I never considered making videos of my lectures. And then all of a sudden, I'm making videos at home every day. 5, 10 minute short ones with my cell phone, putting them online. And then we went to the Zoom environment. And now as a result, every class I teach has all of these resources that previous generations didn't have. So you guys are going to have live lectures where a couple years ago I wouldn't have considered doing this. It's way too much work. But now it's archived. So what I do in my other classes, I even use previous lectures and post them on there. So it's kind of nice. Now, I'm going to go ahead and close this. Whoops. Oh, shoot. I didn't mean to do that. All right, it's going to take me a minute. I'm going to do the lecture, and then what I'm going to do is bring up the ebook, which has really been kind of a headache. So let me do that. And the reason I'm going to bring up the ebook is because there's questions that I want us to do. There's problems that I want to work on in class as a group, and I want everyone to work on them, and I don't think everyone here has access. How many here have their laptops with them? I would strongly encourage you, if you have, here's how I'm going to make an assumption, that everybody here is probably going to buy the ebook, okay? If you have the hard copy, that's great. But if you have the ebook, then bring your laptop to class and just log on. I will put things up here, but that's not to your convenience or to your advantage because you want to flip the page. Right? I'm not ready to flip the page because somebody else is still working on that problem. If you bring your laptop and you can log on to your ebook in class when we start working, That makes it a little bit easier. Plus, I really do encourage you guys to work together. I'm not going to make you form groups. I'm not one of those kind of people. I'm not going to make you put little name cards on the front of your desk. I'm sorry, you've probably all been in a class where people do that and they think this is an awesome idea. Great, yeah, when you're in kindergarten, you're grown-ups. You don't have to work with another person if you don't want to. But I strongly encourage you when we're working to work with somebody because they may know it better than you and they may be able to explain it. Or better, you know it better than them. You can explain it to them. And that makes it even better because then everybody leaves knowing a little bit more. If you've ever worked with somebody or particularly tutored, you know that the tutor is the one who gets the most out of it because they reinforce. But this is a class where we're going to be doing concepts that you may never have heard of or never thought of. So today is going to be fairly short and simple. The class runs from 8 to 11, but the lectures themselves probably will never even be 90 minutes. They'll probably be an hour, hour and 15 minutes. Then it's basically we're going to do stuff, work, until you're done. If you are done and you've done everything you want to do today, you can leave. I'm not going to be offended. I'm not going to be upset. But I really encourage you never leave unfinished. Now, I have office hours every day of the week. My office hours on Monday and Wednesday is the hour between my classes, basically 10 to 11. And my office hours Tuesday, Thursday is 11 to 12:30, basically when we're done for an hour and a half. If you have questions, office hours are some of the best times to ask them. But what if you have a question on the weekend? What if you have a question on the day that the class doesn't meet? Email me your questions. The majority of the questions that I get asked, somebody took a picture of their quiz, put a little sticky note and say a little arrow saying, I'm stuck right here, I don't know what to do next. Or, most common one, am I on the right track? These are great questions. Never wait to ask the question. If you can ask me live, that's great. But if you can't ask me live because you've already gone home, then email me your question. I don't need anybody to come to my office hours, but be aware that the office hours are available for everybody. In about 3 weeks, or 4 weeks, I'm not sure if it's week 4 or week 5, I'm going to be doing a series of Math 15s. I do the 15 D, E, and F. Now the 15s are the self-paced review courses, and we strongly encourage people, even the calculus students, to take these. My office hours will shift at that point to one of the computer labs. And I encourage people to come to my office hours and actually use them. My top calculus student last year, and he was in my class this summer, Head and Shoulders, he would come to, we called them workshops. He would come to the computer lab, the 15s, and he would log on and do pre-calculus. I was in Calc 3. He would do pre-calculus. I said, what are you doing there? He goes, I have some holes I feel like I need to fill. So he would come and work for an hour on doing pre-calculus stuff. It's free because you could just log on and do the stuff. It's my open math that I'm using. And my best student was coming just to get a little bit extra. And he did it several days in a row. And he said, so he finished the entire pre-calculus course that usually is a semester long. He did it in like 3 days. He's smart. But I encourage people that you can come and do that. Now, there is not a stats program particularly, but we are going to be adding a very, very specific stats tutoring to the Mesa College tutoring. We've never had stats tutoring. We've had algebra tutoring, calculus tutoring, never stats tutoring. And so there's a lot of work going in right now to increase the stats tutoring. The problem with stats tutoring is real simple. You get an A in statistics. We want you to tutor next semester. You get an A in statistics. 2 years later, do you think you're going to be very good at tutoring statistics? No, because you're not going to do any more statistics probably ever again after stats. So in other words, they're only good if it's right after the class. If they wait a while, they forget everything. So how does that work in algebra and calculus? Calculus tutors are usually really good at the algebra stuff because it's one continuous sequence. You do all your algebras, then you do all your calculuses. You're redoing all the same stuff and adding to it. That's why the calculus tutors can tutor everything below calculus because they've been doing it for every semester. But stats, most of you will do one time. Unless your major required an upper division version, which is very unlikely, there are not that many majors that do, after this semester you may not do stats again directly. That's why the stats tutoring is so hard because you're finding people who actually can remember their stats. Now, we're going to go through a couple of things. The first thing I want to talk about is basically, what is the point of statistics? How do we use statistics to answer questions? You've heard the term sampling before, okay? Stats is not vague. It's a science, but there's a lot of parts of stats that people don't understand, big pictures. How can people make conclusions using only small amounts of information? I'll give you a perfect example, okay? I love teaching stats during elections because there's so much statistics going on during elections. Everybody here has heard about things like opinion polls, right? Is this proposition going to pass? Is this candidate going to be elected? Whatever. And they'll say, you know, Americans, 53% of Americans feel this way. And every one of you should have the same feeling. How can they say that? They didn't ask me. Has anyone ever had that thought in their life? How can they say that? Well, actually, if the statistics is done correctly, they can't say that. The idea with statistics is you have the whole. The whole might be people, so it might be the entire United States. And I want to make conclusions about the whole. But it would take forever to go through and measure or ask everything from the whole. I can't do that. So if the sampling is done correctly, and we're going to talk about that kind of stuff, I can take a small portion and make conclusions about the whole if I did it right. Now, might I make a mistake? Yeah, there's a little wiggle room there, but usually the mistakes are not that great. So when you hear things like an opinion poll, if you ever pay attention, at the end, they'll always say at the bottom, this poll comes with an error of plus or minus 3%. You ever notice that one? Every opinion poll you'll ever see will always say the same thing, and it will always say 3%. Because there's a way to measure, you can actually measure that. Meaning that I may not hit it exactly right, but I can be pretty accurate. Okay? So we're going to talk about all of these things. Now, one of the biggest problems we face when it comes to sampling or trying to make conclusions, the number one error is something called bias. Now, bias, people have their own interpretation of what bias is. Well, you know, I feel very strongly this way, so I am totally biased. Well, yeah, that might be true. But bias in a statistical sense, that's not really the same thing. Bias is you made a conclusion, but the stuff you used to make the conclusion wasn't truly representative. So one of the fun ones I have, I can remember there was one particular election, and I'm driving off campus. This is one of the things I always hate, living on the left coast. You know, the polls haven't closed, and they're already telling us election results, and you haven't voted yet. Anybody ever had that? They haven't voted yet, they're already telling me who won, I'm not going to bother voting. I hated that. But I can't remember what year exactly, but I'm listening to the news, and they're saying a particular candidate for president had already won all of these different states. By the way, that particular candidate lost almost every one of those states that they were telling us that they won. So however they were doing this, it was really terrible, and people got really upset. Why are you telling us all the East Coast results? It was like 3 in the afternoon here. Don't tell us the East Coast results. But what was interesting, I saw the next day, the reason they got all the numbers wrong is they were standing outside the headquarters of that, I'm not going to tell you which ones, the Democratic or Republican headquarters. They were standing outside the headquarters and asking people as they left who they voted for. And overwhelmingly in each of those states, that particular party overwhelmingly won. Now think about that for a moment. You work for the Republican Party, you work for the Democratic Party, you're leaving your job and they ask you, who'd you vote for? Do you think your results might be a little bit skewed? Think about that for a moment. All right? You're going to go to McDonald's later on today and you want to find out just how many people are actually vegetarians. So you go to McDonald's and interview people at McDonald's, and you interview a lot of people. You feel, my God, 99.9% of Americans are not vegetarians. Do you think your results might be a little tainted? See, this is what bias is. This isn't because you had a bad opinion or something, or you're wrong. You asked a question in such a way, there's no way the results could be truly fair. You know, you would like to find out what percentage of San Diegans love the ocean. Are there? I have a daughter who doesn't love the ocean. She doesn't live in San Diego anymore. She makes me very sad. She's not into the whole sun thing. She'd rather have overcast and rain. Okay, so you want to know, you know, what percentage of San Diegans truly love the ocean? Because there are San Diegans that probably stay away from the ocean. So you want to find out. So you're just going to go down to the beach today and ask everybody you see. Good idea? What do you think your results are going to be?
Skewed.
Well, you probably close to 100%. God, everybody in San Diego loves the ocean. As long as I'm asking people who are, swimming around in the ocean. Again, that's called bias. That's not a good one. Now, another one that's not a good one, and a lot of times we don't think about things like this, but sometimes it's so obvious, you go, that's not really a good one. Another one is a particular company or a corporation that sells a particular item, they will conduct their own research and surveys. Cigarette companies are notorious for this, and they'll put out their own output, but it'll be about something like that. So, it could be a producer of whatever thing, and now they do a poll or survey about that thing. Well, it's kind of self-serving whatever results they come out with, because they're the ones doing the research. It's kind of like the pharmaceutical company who is going to sell this new drug, and then they tell you all the information about that drug because they did their own research. You go, well, of course it's the greatest drug in the world. Whether it is or it isn't is not relevant because they did all the research and they're presenting all the evidence. Again, so sometimes you have to look past it and say, maybe that's not it. One of my favorite type of ones, though, everybody here logs onto their computer or something, right? So you're logging onto the internet, and there'll be a question. You ever get the question, just the random question? What do you think about this? Do you guys ever see those? Every time you log on, there'll be a question about something. And I remember a couple years ago, I'm looking on, and the question had to do with Tom Brady. I think it was when he was leaving New England, and it said, is Tom Brady the greatest quarterback, or something like that. Now, do you have to answer that question? Now, and when you answer it, you're going to get another one and then another one. But just for fun, I answered the question, and then it immediately gave me feedback, and it literally, like hundreds of thousands of people had answered that question. And it even gave it geographic regions. It was interesting because in the Northeast, it was like 99%, and in California, it was much less, in a particular place. But this is called a voluntary response sample. Now, according to the numbers, Tom Brady was the greatest quarterback ever because hundreds of thousands of people answered this poll. But people chose to answer the poll. So, can you trust that result? Whether it's right or not, can you trust that result? This is one of the most dangerous. A voluntary response sample. It could be somebody's they have a stand outside, right? And you're walking by, and they want people to come and fill out a survey. You guys have seen things like that all the time. They want you to fill out a survey, and you're like, no. Most of you, no, I don't want to fill out a survey. Okay, I'm waiting for my friend to come pick me up. I have a few minutes. I'll go ahead and fill out the survey. And they get a lot of people filling out the survey. And now they're going to have results and present results. Problem is, you chose whether to fill out the survey or not. So again, the results they get may not be entirely accurate. It's called, again, a voluntary response sample. So you got to be really mindful of that. Does anyone here ever read Yelp reviews? Yeah, you're going to a restaurant, maybe you've never heard of it. Okay, when you go to a restaurant, how many here actually will fill out a review of the restaurant? Because I have fun with this one. You don't have to. So most people say, I never would. Yet, you'll go to the Yelp review, and you will read it, and you will trust it. You will trust something that you yourself would not ever fill out. See, a Yelp review, again, it's not a survey, it's a voluntary response sample. Now, when people do voluntary responses, do they tend to do them when they're really, really happy with something or when they're not happy with something?
Both.
Like you had a great experience, are you more likely to go online and fill something out? Or if you had a bad experience, are you more likely to go online? Usually the negative, most people say, yeah. You want to swing by the dean's office later on today and say, oh, Dean, I just want to let you know I have this great teacher over here, they're doing a great job. Or you're more likely to go by to complain about something that they did that you didn't like. So in other words, the voluntary response sample is usually not very trustworthy just because it's not a true representation of everybody. So here's one of the problems I'm going to refer to all semester. We want to find the average height of a Mesa College student. Maybe we want to market a line of clothing, and we don't have the money to do many, many, many sizes, so we want maybe just Let's pick a size that's most reflective of most people. I want to find the average height of a Mesa College student. Now, in most semesters, pre-pandemic, we have around 27, 28, 29,000 Mesa College students. So are you going to be able to measure every single student's height and weight? No, you'd have to figure out a way of doing this. And we'll talk about how to do this. So if you wanted to do this, do you want people to volunteer their height and weight? Or do you want you go out and measure things randomly? So you want to measure people's height and weight, and so you got the football and the basketball team. You got all their heights and weights. Do you think that would be reflective of the average Mesa College student? Or are they more likely going to be larger than the average Mesa College student? So in other words, that would be not a very accurate result. So one of the things that's the most important when it comes to something as simple as trying to make a conclusion by taking a sample is sampling has to reflect the population that you're dealing with. And so therefore you hear the term random all the time. So a random sample, and we're going to spend a lot of time on this next day, a random sample is a sample where every single person or thing you're sampling from, everything is equally likely to be chosen. Now, whether you're chosen or not is irrelevant. It's the fact that you are just as likely to be chosen as someone else. That is really, really important. Now, again, next day we're going to spend a little more time on this. Let's suppose you're in a situation, it's a college campus, okay? And we want to find out next year, we're talking about potentially raising the tuition costs because we want to fund maybe like a daycare center on campus. Okay, so that's a cool thing. And we've done that before at Mesa College. We want to fund a daycare center on campus. But that means your fees are going to go up as a result. So we want to find out, are you likely or unlikely to vote for this? Because maybe we're going to put it up for a vote for the students. That seems like a fair thing. Well, so I'm going to randomly ask, and half the people I ask have kids, and half the people I ask don't have kids. The people I ask that have kids, do you think they're very likely to want to approve a daycare center? Yeah, little kids. You say, yeah. And the people that don't have kids, maybe some of them are. But then I look at the numbers later and I find out only 1% of the students on campus actually have children. I said half the people I asked had children, but only 1% of the campus actually has children. Are my results trustworthy or are they biased? They're going to be extremely biased. If out of every 100 people, only one of them has kids, then I should not have 50 of the people I ask have kids if I'm only asking 100 people, because the results are going to be really misrepresented. Now, it's not about, well, should we have it or should we not have it? No, my sample should reflect the population. Oh, okay. So we're going to talk about that one next day. But when you sample, if your population, let's say, was evenly distributed male and female, then shouldn't your samples be basically half male and half female? Would that make sense to you? If you said, well, I have a campus that's evenly distributed male and female, but my sample 80% were male. Well, I'm not sure I could trust the results then, because it would be very biased towards a male opinion. I would really want it to be 50-50. Another one would be age, for example. Let's say half the campus is over the age of 21, and half the campus is 21 or less. Then if I do a poll, shouldn't I take age into account when I'm asking people the question? If the question might be about something age-worthy. You'd say, yeah, that's kind of a common sense thing. Do you agree? That, yeah, my sample should reflect the population. Now, we're going to go into this heavily over the next few days so we understand, because we want to get it right. So when I talked at the beginning about opinion polls, who's going to win president and stuff like that, oh, there is so much research involved in polling. It's unbelievable, the detail and research, because if we're going to ask 1,000 people in a country of 330 million people, we want to make sure that 1,000 people is a snapshot of society as a whole. So if you think of ethnic groups, age groups, right, gender, socioeconomics, do you have kids, do you not have kids? You think of all of these things that may potentially factor into somebody's decision, you would want your sample to roughly reflect the population in terms of their percentages. That's why in most of these situations you really can trust the results, because they went into so much great detail to make sure the sample reflects the population. Because if I don't do that, then I really can't trust the results, because they would be very biased. See, that's what the bias is. Bias isn't that, a lot of people think bias is a negative thing because it's about me. No, bias is it's not a reflection because one group may be overrepresented, which also means that some group is underrepresented. And then that, again, I don't know if that's a true thing, okay? Now, next thing I want to talk about is some of the vocabulary words, because the type of things. Now, we use words like data all the time, okay? So we want to talk about the types of data. Okay, now, there's many different subgroups. There's about 10 different words I'm going to go over, but it's not, you have a choice of 1 in 10. Sometimes it's this word or this word, and then this word or this word, and so on. So when it comes to numbers, has anyone here had calculus or above? Not too many people. You hear words like continuous, okay? Well, the first thing when it comes to numbers or numerical data, let's sound really, mathy. Numerical data. I want to know how many siblings do you have? That would be a numerical piece of information. I want to know how tall are you? That would be numerical. I want to know how old are you? That's numerical. Okay? I want to know who you voted for president. That's not numerical. Okay, that's something completely unrelated. So numbers are either discrete or continuous. It's one or the other. There's no gray area. If you've ever had a lab science, chemistry, physics, you understand measurements. Okay, I have to measure something. I have to measure the weight of something. I have to measure the length of something. Maybe it's a person and I want to measure your age. Every form of measurement there is continuous, because every form of measurement there's an infinite number of decimals. For example, is there anyone here who's 6 feet tall? Okay, so down to the subelectronic particle, if I measure your height, you would be exactly 6 feet. In fact, good hair, bad hair days might get an extra ½ inch, right?
Yeah.
Or would we say to the nearest inch, you're 6 foot 0 inches?
Yeah.
That's probably safer. You're probably then safely between 5'11 and a half and 6 foot and a half. That would be a safe. Now, how many heights are there in that little range? Infinitely many. Now think about that. When you measure something, when you report it. If I asked you how heavy you were, you'd say, I'm 150 pounds. 150 exactly? Like on a scale it would be 150.00000. No, to the nearest whole number I would round it to 150. When you weigh yourself, there would actually be an infinite number of decimals, but nobody reports the infinite number of decimals. So when I say, what's your GPA? You say, oh, it's 3.74296533. You can go on forever and ever. Or you probably just said 3.7. Okay? Any form of measurement technically has an infinite number of decimals, because you can't be exactly 6 feet tall. Is there anyone here who is 21? So, you just turned 21. Right this moment was the date you were born at 8:53 a.m. on August 22nd. No. You've lived 21 whole years and some change. When we report our age, don't we just give the whole numbers? Unless you're under 10. See, if you're under 10, you say, I'm 9.5 or 9 3/4, or, my birthday's next week. But most of us would give a whole number of years. That doesn't mean we were born exactly that many years ago today, right? So your age is continuous, but you report a number because it's convenient. So continuous is anything that can be measured. All measurements are continuous. Then what's discrete? Do you have any siblings?
Yeah, two.
How many? 2? Wait, not 2.7?
No.
Or 3.5 or square root of 6? You have 2. Could you have 1? Yes. Could you have 3? Are there any values between 1 and 2? No, you have 1 sibling, you have 2 siblings. There's nothing in between. This is discrete. If you can count it, it's discrete. How many units are you carrying this semester?
15.
Oh, okay, 15. Not 14.7 or 19. It's exactly 15. Could you have 60? Yes. Could you have 14? Is there any number of units between those two you could have? No. You can have 14 or 15 or 16. There's no values between. In continuous data, between 14 and 15, there's an infinite number of possibilities. Think a measurement, a length. Something could be 14 centimeters, something could be 15 centimeters. There's an infinite number in between. So discrete is when I'm counting things, like number of units, number of siblings. Your age isn't discrete, but what we do is we take continuous data and we report it with discrete numbers. Last time I checked, I don't think I ever heard anybody give their age in decimals. So you say, well, I'm 19.73. Hold on, 7.4. In a few minutes, 7.5. I don't think any of us do that, right? So discrete is what we spend more of our time with in statistics because it's easy. I'm going to flip a coin 10 times. How many tails can I get? Well, I could get 0 or 1 or 2 or 3 or 4, all the way up to 10. There would be no decimal possibilities. Do you agree? So, discrete, I'm counting things. Continuous, I'm measuring things. That's, any number is one of those two things. Okay? Now, excuse me. There's a different type of data. There's something called quantitative and qualitative, and that is also referred to as categorical. So this is kind of a bigger one. And I like to use this. All right, I'm a big Kobe Bryant fan. Okay, Kobe Bryant had 2 different jersey numbers. Anybody know what they were?
24 and 8.
Good, 824. Good Kobe. That's got to be worth at least, 100 miles. Oh, just so you know, I give out airline miles. Good answers get airline miles. At the end of a semester, some of you will accumulate a lot of airline miles. Now, they're not redeemable for anything and they have no cash value, but it makes us all feel good when you say, God, yeah, I got 1,000 miles in that one. Yeah, so that's a good answer. All right, so do I take the number 8 and somehow use it in a calculation? Does the number 8 have any numerical value to me? Or is that just a way of identifying Kobe Bryant from somebody else? So his number 8 would be called qualitative or categorical. It has no numerical value. Now, Kobe scored 20 points last night. Can I talk about now that as like maybe his average points for the year or for the week or something? He scored 20 points. That's something I counted how many points he scored. He could have scored 30. He could have scored 10. He scored 20 points. That would be quantitative. Think quantity. If something is a number where I can actually use the number to make a conclusion or a calculation, like how many points you scored, okay? Your street address has a number. Does that number have any numerical value? Can I average it with other numbers? Or does the number reflect somehow, how much money I'm going to make or how much debt I have? Or is it just the name of where I live? Think about that. Your street address, is it just the name of where you live or does it have any numerical value? It's just the name of where you live. That would make it qualitative or categorical. See, not all numbers. By the way, we're in room 318, so we're one better than the people in 317. Do you agree? But that would make us, the 320 is next door, so we're not as good as those guys. Is there any numerical value to the room 318? Or is that just the name of our room?
It's just the name.
Well, isn't like the higher numbers are higher off the ground, right? Like we're further.
Well, 3rd floor, yes, but 320 is next door. Do those numerical values mean anything to us, or are they just the name of the room? Do you understand that sometimes a number is not a number? It's not a value. It's the name of something. So your jersey number when you played a sport in high school didn't reflect anything about you because sometimes your jersey didn't have your name on the back. And so they identified you by what number you were wearing. Did that number mean anything? No, it was the name of you. Your street address is a perfect example. The room number we're in. Oh, now, how much money you have in your pocket? That's something you can actually count. How old are you? That's something that can be counted. That's called quantitative. So qualitative, really think of it, it's just the category. What room number are you in? Now, when you vote, if there are multiple candidates for whatever you're voting for, they'll usually be numbered, 1, 2, 3, 4, 5. So you vote for candidate 1, you vote for candidate 2, you vote for candidate 3. Do I add up these numbers somehow? No. You were arbitrarily chosen to be the first candidate. Somebody else was arbitrarily chosen to be the second candidate. Those numbers don't mean anything. It's just instead of the name of the person, we're going to put a number in front of them to keep track. So when I'm counting things in that regard, I'm just saying who got the most votes, how many times did the number 1 show up, how many times did the number 2 show up. I don't average them together. I don't add them together. So quantitative and qualitative are usually really easy to distinguish. This is, think of as literally like names in that sense versus numbers that are counted, okay? Now, when we're talking about statistics, there's another word that goes with it called a parameter. Now, let's keep it simple. Let's say we're talking about the United States. We're talking about people in the United States. So I can say the average income of the entire United States. Well, do I have to have a sample for something like that, or is that kind of information actually available? We talk about the average number of people in households in the United States. Yeah, it's called census data and IRS data. Why is there a census? A census is so I literally can, without having to sample, count every single person in the United States and say how many people are doing this and how many people are doing that. How long does it take to collect the census data? Anybody know?
2 years.
Yeah, somewhere between 1 and 2 years. So by the time we're done collecting the census data, is it accurate anymore? No, it's ancient. And how often do we do it? Every 10 years. But it's something to start with. IRS collects the data every single year, and it's of every single person who supposedly earned money. Some people may not file their taxes, okay. But I have all of the numbers. If I have everything of a population, it's called a parameter. A parameter is a numerical value that represents the entire population. In most areas in life, you don't have the ability to do that because it's just too big. If I wanted to say, well, what is the average size of a water molecule in the ocean? That's a lot of water molecules in the ocean. Do you think I could measure all of them? Yeah, it might take me a couple of days, or maybe a few thousand lifetimes, I don't know. So there are things that I probably can't measure everything. So if I have every number in a population, like a census, like IRS data, it's possible that parameters. But if I don't have every number, then what I do is I collect a sample. I collect a sample, and any value that I measure from a sample is called a statistic. That's what the word means. A statistic is any numerical value or anything you did based on a sample, whereas a parameter is what you did based on the population. Now, what if the only thing we cared about is this class? We don't care about other classes. We don't care about the rest of the campus. We are a self-contained unit. So if we have an exam, and we have all of the numbers on the exam, and we report, let's say, the class average on the exam, would that be a statistic or a parameter? If we're the only ones we're talking about, that would be a parameter. Now, if we were saying, okay, all of the statistics classes in the district, let's talk about our class average. Would that be a parameter or a sample or a statistic at that point? Yeah, because we're saying we are one of many. The whole would be all classes, we're just one. So a parameter is when you have the whole, you have the entire population. Doesn't matter how big the population is, you have everything there. There's a lot of times we will have the entire population, okay? We won't always, right? Now the last group of names I want to go over, these are the ones that most people concentrate on. There's a group of 4, nominal, ordinal, interval, ratio. And every stats book goes through these in great detail. Now, when I'm doing measurements, again, a lot of times it was one versus the other. Here's one versus the other. So now I'm collecting information, because a lot of times when we collect information, we want to report averages, right? We want to report things about population. So let's suppose we're going to put on the first Mesa College dance. We've decided to put on the first Mesa College dance, so we're going to advertise it heavily. We have to choose the music, don't we? So we have to decide, we want to choose music that's most representative of the population, Mesa College students, that's our population. So we go out and we ask people, but how do you ask music choices? So we're just going to make a list. And let's say we come up with literally 20 different, the number one would be, let's say, elevator music. And it gets, maybe, 10 would be, I don't know, electric polka. I don't know. It goes eventually, as my youngest daughter got, the last one, of course, would have to be screamo, right? We just say that's like the most extreme. And so we give everybody the choices, 1 through 20. And so you selected 5, you selected 13, you selected 7 as your favorite music. And what we want to do is pick a music choice that's most representative. So what we did was we took all of your choices, we added them up, and we divided by the number of people, and we came out with, the numerical average was 10. So we're going to have the first ever Mesa College dance with, electric polka, as the, lots of accordion. But when we went back and, we looked at tens of thousands of people filled this out, and no one actually selected 10. It was the average of all of our choices. Did we do something wrong? Well, first of all, number 1 was whatever music choice we put there. The 1 doesn't have any numerical value. It was just the choice. If we wanted to get it right, what should we have done? If I wanted to select the music that most represented the campus, shouldn't we have selected the choice that came up the most often? Didn't that make more sense? Oh, because these weren't numerical values, they were names. This is what is called nominal data. Literally in name only. When I selected the music choices, those didn't have numerical value. Number 1 represented this musical choice. Number 2 represented this musical choice. There's no numerical value in the 1 and 2. So with nominal data, the only thing you can do is just count the most commonly occurring one. So when we're doing an election, you don't average the candidates together. You take the candidate who got the most votes. You don't say, well, let's average candidate 1 with candidate 3 and we'll get candidate 2 as a result. No, it doesn't work that way. Now, the next one, ordinal. Another way of thinking about it is ranking. Okay? I have a list of people in this class. I could organize you in any way I want, couldn't I? I could go youngest to oldest, oldest to youngest, tallest to shortest. But the organization that I choose is alphabetical. It's easier to keep track. So if you're number 1 on my list, great. Does that 1 have value? Or is that's your position on the list because I've ranked you? Now, think of it another way. We're going to have a race. We're going to have a race. Finishing first is great. It's better than finishing second. And finishing second is better than finishing third. But is the difference between finishing first and second exactly the same as the difference between second and third, and exactly the same between third and fourth? Would it work that way? Not exactly. Where you rank is where you rank. That's a number that means something. I'm number 1. I'm number 2. That's not just an arbitrary choice. I was the number 1. I was the top. I had the best time, or I had the highest score. But ranking, I can't take those numerical values. That would be kind of like saying we have 10 races, and you finished first 5 times, and you finished third 5 times. So that means your average was second. It doesn't really work that way. I don't average your rankings. I just say you finished first 5 times. Now, what's interesting, if you ever watch the Olympics, okay, figure skating. I always use figure skating. I use that in my calculus classes when we talk about center of mass. Figure skating is a very interesting sport because you'll have all the judges and everybody gives scores. But your score doesn't mean anything. It's where they ranked you. So you got 5 first place rankings and 4 second place rankings. You're now in the lead. But what if the person who got 4 first place and 5 second places had higher scores overall? No, the other person's still going to win. They go by who had the most first place votes. They put a score, but they don't go by the score, which is kind of ironic. Okay? So rank, yes, that means something, but I can't average rankings together. That doesn't mean anything. Now, the next one is the most confusing of all because this is a numerical value. Interval is numerical. And the simplest examples of interval are time and temperature. Because in interval, there's technically no zero. I'll use temperature as an example. Let's say it's 0 degrees outside. Let's say it's 10 degrees outside. Let's say it's 20 degrees outside. It's 30 degrees outside. 1 degree is 1 degree. 1 degree always means the same thing. So from 10 degrees to 20 degrees, that 10-degree difference is exactly the same as from 80 degrees to 90 degrees. It's the same 10 degrees. But does that mean that 20 degrees is twice as warm as 10 degrees? Is 100 degrees twice as warm as 50 degrees? Or is it just 50 degrees warmer? Because does 0 degrees outside, I'm talking Fahrenheit, does 0 degrees outside mean the absence of all temperature? No, because you could be then -10. Go to Green Bay, -50. Oh, because temperature, I can now go into the negative. 50 degrees is 10 degrees more than 40 degrees. But it's not twice as much as 25 degrees. It doesn't mean it's twice as warm. That's not how temperature works. I just do the degree. Now think time. It's 2 o'clock in the afternoon. 2 hours later, it's 4 o'clock in the afternoon. 2 hours later, it's 6 o'clock. Because 2 hours is 2 hours is 2 hours, regardless of what time of day. Is 4 o'clock twice as late as 2 o'clock? Wait a minute. Nobody talks about that. No, 4 o'clock is not twice as late as 2 o'clock because there's no 0 o'clock. Right? If it's 2 o'clock, then 4 hours ago it was 10 o'clock. Boy, that's really confusing, isn't it? But in a clock, an hour is an hour, regardless of where it is. But you can't say one time. 9/11, that's the time right now, is 1 hour later than 8/11. But it's not twice or 3 times some other time. So time and temperature, the units mean something. A degree is a degree no matter where I put it. But again, I can't say one temperature is twice as much as another temperature. Or one time of day is twice as much as another time of day. Does that make some sense? Ratio data is the data I can do that with. You got $10 in your pocket. Is that twice as much as $5 in your pocket? Yes, because $0 in your pocket is 0. You don't have anything. There is a 0 that has meaning. In interval, there's no 0. That's why you can't talk about twice as much and things like that. So ratio data, first of all, there is a 0. There is a 0. Is 6 feet twice as long as 3 feet? Yes, because 0 feet means 0. There's nothing negative feet. There's nothing, you can't go the other way. Okay, so ratio data, averaging makes perfect sense and things like that. Okay, I can average temperatures. I can do that. I can't really average the time on the clock, though. That'd be kind of a weird one. But I can average ratio data. That would be like ages, any form of measurement. When we're doing discrete data counts, I can use those. I can average those. So when asked a question, okay, Kobe Bryant, you say he was wearing number 8. What type of data is that of these 4?
Nominal.
That's nominal. Kobe scored 20 points. What kind of data is that?
Ratio.
That's ratio. Kobe was the leading scorer in the league this year.
Right.
Good. Because he ranked number 1. His 20 points I can average with other games because he could have had 0, couldn't have had negative. Does that make sense? I just gave you one person, I gave you 3 different things and ways to look at that data. Yeah.
So is interval like qualitative? Could you say
Interval is qualitative. Oh, these 3 are all qualitative in the fact that the numbers mean something. We're in room 318. You got 318 on the first exam. It's 3:18 on the clock. Room 318. You got 318 on the exam. The time is 3:18 on the clock. You were the 318th person in line at the cafeteria. that make sense? Okay, I'm going to stop there. I'm going to stop recording there. Can you go ahead and hit the red button?